Actually,
Wait, when'd you check?
I think I'm recording.
I unsubscribed.
I didn't hear the thing though. Hello and good day, pre-algebra. We are moving on a Friday to CO11 because everybody wants to talk about exponents and roots on a Friday. So exponents and roots are those two letters of PERMDAS that you're probably the most unfamiliar with. So they get their very own objective. CO11, and because you cannot use a calculator on this section of the test, we are going to go over what these values are, okay? So that when you see what 1 squared is, you know what the value of 1 squared is on the test, which 1 squared would be 1, okay? What, right? What an exponent means is whatever the base is, whatever is being squared, 1 times 1, that's how many 1s are being multiplied together. So 2 squared would mean 2 times 2, and that is 4. 3 squared would be 3 times 3, which is 9, right? 4 squared?
16.
16. 5 squared? 25. 6 squared?
36.
36. 7 squared?
49.
49. 8 squared?
64.
64. 9 squared?
81.
81. 10 squared?
100.
100. 11 squared?
120.
Close.
122.
These charts should be being filled out right now.
110.
Put this on a help sheet. You can't use a calculator on a help sheet. You can write these charts down. 11 squared is not 110, not 120, not 144, not 122, 121. 121 is 11 squared. 12 squared, Jimena? 144. They get a little more difficult the higher that we get here. 13 squared? This is the highway that runs, many of you probably take it to get here. What?
169.
169? 14 squared?
Can you use my calculator? No. Wait.
To find it now.
We didn't have to do math facts on this in third grade. 196.
196. 15 squared?
Oh. My goodness. 225.
225. And finally 16 squared?
3 million.
Nope. That would be
256.
256. Okay. So if you weren't able to come up with these, right? That means on the test you're going to have the same struggles. Put this chart on a help sheet. Take the time to fill it out, put it on a help sheet so that you have it. It's got all the squares that you will need for the test. Okay? And then the second table there deals with the roots or radicals. Remember that exponents and roots are opposites. They're opposite operations. One undoes the other. Okay? So you're going to see some connections here as we fill this out. If you see the square root of 1, what that's asking for is what times itself equals 1. What is the root of 1? 1. Okay? Your next perfect square, it's called, because it works out evenly, is 4. What number times itself is 4?
2.
2. Your next perfect square is 9.
3.
Nothing times itself equals 6, right? 3 plus 3 is 6, but we're talking about multiplying here. The root of 9, 3 times 3 equals 9, so the root of 9 will be 3. The root of 16, what times itself is 16? 4.
Why is it 8?
The root of 25, what times itself is 25? 5. And you might notice some connections here, right? Take a look at this. If we start with 5 and we square it, we get 25. If we then take the root of 25, we get back to 5 again. That's how exponents and roots are opposites. If you square something to get back to the original value, you can take the root. So our next perfect square is the root of 36, which is 6. And then we have the root of 49,
7.
which is 7. What's our next perfect square?
64.
64, right? Because if you square 8, you get 64. To undo that, you take the root of 64 and you get back to 8 again. What's our next perfect square? 81. We're starting to pick up on this now. And the root of 81 is 9. Then comes
100.
100,
One.
which is 10. Then 121, the root of that is 11. I'll move out of your way so you can see in a little bit here. 144 is 12. Root of 169 is 13. Root of 196 is 14. Root of 225 is 15. And we end at the root of 256, which is 16. We've come full circle here. Okay, you start with a value and you square it. That's what the top chart is. To undo that, you take the root of it. And that's what the bottom table is. Okay? And in case someone isn't here today and needs to see this, we will capture the ink for later.
Well, this will be fun. Don't say. What the heck? Look at that.
Yeah. Does that look like fun?
No.
Exactly. The top part does.
Anyone still filling this out?
No.
Okay.
Nope.
Anyone? Who? Oh,
Did
okay.
it say numbers at the top?
Pretty much, yes. There is a definite connection here.
Well, actually, that doesn't look that hard.
Really?
No. We just do 8.
Oh, wait, actually, that doesn't. 13. Wait, what's 3 quadrupled? Or whatever. This is 4 to 12.
We good?
Up.
Yeah.
Okay. So you are now armed for the bottom section without using a calculator because you have all of these values. 2 things to watch out for. These are things that I see very often. 3 squared is not 6. We talked about that. It's not 3 times 2. You know, 3 squared is 3 times 3, which actually equals 9. The other one that comes up a lot is folks want to just take a root and they think it means divide by 2. Okay, it doesn't. It means what times itself is the number under the root. So root 16 is not 8. The root of 16 would equal 4 because 4 times 4 is not what plus itself, it's what times itself. So just watch out for those little errors there. So it says, use the tables above and the order of operations to evaluate the following expressions. These, you can just look at the table for, so I don't really want to go over many of them, but if you see 11 squared, that means 11 times 11, right? And which equals, look at the top if you don't know, 121, right? It's just kind of regurgitating that. The root of 196, what times itself is 196? 14, it says in the table at the top, okay? Where you have to think a little bit more is when you get down to this section here. For example, let's take this one. 12 plus 6 squared times the root of 4. There are 4 operations going on here. You got addition, squaring, multiplication, and the root. According to PERMDAS, what do we need to do first? Not when there are exponents and roots. Those exponents and roots have to happen first.
Well, like, 6, you know, I feel like, would it be like 36 and 12 plus 30 at 36?
Yeah. So, but not, we're not going to add first though because we do have that multiplication. But yes, you're absolutely right. So this squaring, we have to do that first. That's the E in PERMDAS, right? So 6 squared is 36. And we're multiplying that by the root of 4. So we have addition, multiplication, and a radical. What gets done next?
Then, radical.
The radical. P-E-R. R. Okay? The radical. What is the root of 4? 2. Right? What times itself equals 4? 2. So now we have addition and multiplication. P-E-R-M. The multiplication has to happen next. Anyone know what 36 times 2 is off the top of their head?
72.
72. And 12 plus 72 gives you 84 as a final answer. So this objective is going to focus on every single question has some sort of squaring or a root. So you get to practice the E and the R in addition to the other operations too. But yeah.
What about the next?
The next one, yeah. So this is actually root of 36 over 121. You won't see this in pre-algebra too often. This is more of an algebra type expression, but I just want to introduce you to it. One of the things about roots of fractions, you can actually take this, the root of a fraction, and rewrite it to be the root of the numerator over the root of the denominator. You can kind of split up like like that, right? Because if you're thinking, man, the root of a fraction, the root of 36 1/21, what times itself is 36 1/21? If you break it up into the numerator and the denominator separately, what's the root of 36? 6. What's the root of 121?
11.
11. And there you go. The root of 36 1/21 is 6/11. So when you see the root of a fraction, don't be scared. Just kind of break it up. Put the root of the numerator over the root of the denominator and solve them separately. Alright? And that's the only one that shows up on here like that. So, Lila.
I'm just wondering, when is this going to be used in life?
Well, you're gonna have homework for the weekend, so you use it tonight, or maybe Sunday night, or hopefully not Monday morning. But next week you have a test. You'll use it on the test.
No, like
out of
College and like when
Well, it depends on what you're going to. You know, I mean, you can thank all of your snaps and your tic tacs and your instas and your finstas and your tinstas and all that sort of stuff. You can all thank math for that, right? Because everything is a computer mathematical program
yeah, what if you like
that is used. So, you know, if you end up not using this in life, then thankfully someone else is, so you can enjoy all of your stuff. Okay?
Do you enjoy the same stuff that we enjoy?
Probably not. I don't have my instas and my finstas and my tic tacs and my snaps.
are you just the type of person who watches cat videos all
He's the
day?
type of person.
I watch Mario videos.
Oh, you're that
I'm,
type of person.
I'm that kind of person, yeah.
Yeah. You're James.
Okay, your assignment for Monday is the rest of the page. We'll do one more together in the spirit of Christmas. Which one would you like to do? Brandon?
None of them. The last row, the third one.
Third one, last row. 1 to the 8th times 3 to the 4th plus the root of 64. So according to order of operations, okay, P, no parentheses, E, we've got some powers here. So the exponents that we have 1 to the 8th,
I think I did it.
and we have 3 to the 4th. We can do those at the same time because they're both powers, okay? And we have to do them before we do the multiplication anyway. So what's 1 to the 8th? 1 times 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 1. 1. Okay, 1 to the 8th means 1 times itself 8 times. Okay? 3 to the 4th means 3 times itself 4 times. Right? 3 to the 4th means 3 times 3 times 3 times 3. Who knows what that is? 81.
Oh, what? I did that totally wrong.
Okay? 3 times 3 times 3 times 3 is 81. So we have 1 times 81. And now we have plus the root of 64. P, no parentheses. E, we've taken care of the exponents. Next up is R, radicals.
8.
The root of 64 is 8. So you have 1 times 81 plus 8. We will multiply first. 1 times 81 is 81. Then add the 8, and we get 89 as a final answer. Okay? So there you go. Rest of the page, including the critical thinking down at the bottom. It says, using an exponent in one and a radical in the other, write 2 expressions, not just one expression, 2 expressions that each equal the page number. And what is the page number? 23. So you're writing one expression that uses a power. You can use anything else, but it's got to have a power, equal 23. And then another expression that uses a root. You can use other stuff too, but it's got to have a root, to equal 23. So two expressions, one with a power, one with a radical, other stuff too, but they both have to equal 23.
Yeah, so you.
Right, so you use other
So you
stuff
like
too.
add or subtract.
Exactly. You can use addition, subtraction, in addition, but it has to have a power, it has to have a root, other stuff can be used as well. Okay, that's high math.
Don't forget to like and subscribe.